massive marine reptile larger than a school bus prowls the shallow, warm waters of the late Cretaceous Ocean, its enormous jaws lined with conical teeth, its paddle fins cutting silently through the prehistoric sea. For decades, scientists believed they understood this creature completely. They were wrong about almost everything. Textbooks and museum halls once offered a single, unyielding portrait of the mosasaur. In these classic reconstructions, the animal glides through ancient seas with the precision of a torpedo, its body streamlined, 4 powerful flippers pressed close, a tail flattened like a shark's to drive sudden bursts of speed. The jaws gape wide, revealing rows of conical teeth, each one shaped to seize and hold slippery prey. For decades, scientists described these teeth as perfect tools for grabbing and swallowing fish whole, or for tearing into the soft bodies of other marine reptiles. The prevailing model was simple: a marine superpredator, lurking in the shallows, waiting for the right moment to lunge and clamp down with a crushing bite. This grab-and-swallow hypothesis was repeated in every major monograph, reinforced by dioramas and documentaries, and rarely questioned. The image was elegant in its clarity, an apex hunter, perfectly adapted, its story seemingly complete. But as paleontologist Takuya Konishi has pointed out, science is never finished. Every fossil carries the possibility of contradiction. And for mosasaurs, that contradiction was waiting just beneath the surface. In 2021, a fossil jaw unearthed in Morocco's phosphate badlands shattered the old image of mosasaur simplicity. Nick Longrich and his team announced Xenodens kalmanichari, a sea lizard unlike any seen before. Its teeth, short and tightly packed, formed a continuous, serrated blade running the length of the jaw. Each crown was compressed and hooked, more like the slicing edge of a shark than the conical piercers of textbook mosasaurs. The dental battery created a living razor, built not for gripping, but for cutting flesh and bone with each snap of the jaws. Longrich described it as so strange, it seemed almost fictional, a creature that could shear through prey, carve chunks from larger animals, or scavenge the remains of giants. This was no blunt instrument. Here was a predator evolving surgical precision, dismantling the classic story, tooth by tooth. A single fossil from the Netherlands, its bones locked in limestone for 70 million years, delivered a blow to the old story. Inside the rib cage of a Mosasaurus, paleontologists uncovered the shattered remains of a fish, its vertebrae scattered and broken, some longer than the mosasaur's own skull. The evidence was unmistakable. This was not a neat, whole meal. The predator had torn its catch apart piece by piece, actively dismembering prey before swallowing. No longer could scientists claim mosasaurs simply gulped down whatever they caught. Seeking answers, the Della Justina team turned to finite element analysis in 2026, digitally reconstructing the bite mechanics of Mosasaurus jaws. Their models revealed something unexpected. The highest stresses didn't align with a crushing grip, but with a shearing action optimized for slicing through flesh and bone. The jaws acted less like a vise and more like a set of powerful scissors, capable of processing prey far larger than what could pass through the throat in one piece. Each line of evidence chipped away at the myth of the simple apex predator. The classic image, grab, crush, swallow, was collapsing under the weight of new data. Instead, the mosasaur emerges as an active processor, capable of striking, slicing, and dismantling its prey. The story was changing, fossil by fossil, from blunt force to calculated precision. In 2025, a single mosasaur tooth surfaced from the riverbeds of the Hell Creek Formation in North Dakota, a place famous for its dinosaurs, not for marine reptiles. The tooth was found deep within a channel sandstone, locked beside a Tyrannosaurus rex incisor and a crocodile jaw fragment. This was not the briny silt of an ancient sea, but the sediment of a meandering river, far from any marine shoreline. Geochemical tests on the enamel told a story that ran against everything paleontologists had believed. The oxygen isotope ratios matched those of freshwater crocodiles, not their ocean-dwelling kin. The enamel was pristine, untouched by marine abrasion, and the surrounding matrix bore no trace of sea life. Melanie During, who helped analyze the specimen, called the chemical signature unmistakable. This mosasaur had spent its final days in a river, hunting alongside dinosaurs and crocodiles as the Cretaceous drew to a close. Barry Albright, a veteran of Hell Creek fieldwork, confirmed the context. These were not fossils washed in from a distant sea, but the remains of animals that died together, buried in a floodplain. The evidence was undeniable. The old image of mosasaurs as creatures forever bound to the open ocean was crumbling. Fossil by fossil, the story was being rewritten, not just a sea monster, but a predator capable of invading rivers, pushing the boundaries of its world as the end approached. Inside the fossilized skulls of mosasaurs, a different kind of evidence was waiting. In 2024, digital endocasts revealed a brain shaped by vision, not scent. The olfactory bulbs, once thought to guide these predators through murky water, were modest, almost vestigial. But the optic lobes, the neural machinery for sight, were massive, dominating the cranial cavity. The ratio of optic to olfactory volume stood far above that of modern crocodiles or snakes. Neuroanatomists working from these metrics argued that mosasaurs hunted with eyes tuned for clarity and speed. They tracked movement in sunlit shallows, relying on precision and timing, not the drifting trace of a scent. The old image of a lurking, smell-driven ambush hunter was gone. In its place stood a reptile that killed by sight, an apex predator, guided by vision in a world that demanded constant adaptation. One by one, the old certainties have fallen away. The vision of mosasaurs as single-minded, open-ocean killers has been dismantled, fossil by fossil. Serrated teeth in Morocco, shattered fish bones in ancient seaways, a lone tooth in a vanished river, and brain cases built for sight pulled at the edges of the classic story. Instead of a static apex predator, the evidence reveals a lineage in flux, slicing, tearing, invading new waters, and hunting by sight. These were not finished products, but restless experimenters, adapting, diversifying, and pushing evolutionary boundaries until the world changed forever. Each fossil dismantles the old myth, revealing predators in constant flux. Science was wrong about almost everything. The real question: what could these evolving hunters have become if given more time?